All right, let's dive right in. Literally every single second, thousands of tiny lights are rolling off production lines all over the world, completely changing how we light up our lives. So, welcome to today's Explainer, where we're going on a virtual factory tour. We're going to uncover exactly how these ubiquitous, energy saving marvels are actually made. We'll go from the microscopic electronic components all the way up to the finished product that's sitting in your living room right now. We're talking advanced automation, crazy precision engineering, and some seriously strict quality control. Look at this number, 90%. I mean, the sheer magnitude of that is just incredible. To understand why this technology is such a big deal, you have to realize that these tiny bulbs consume up to 90% less electricity than those old-school incandescent bulbs we all grew up with. Plus, they generate way less heat, which makes them safer and exponentially more efficient. We're talking about a massive global reduction in power consumption, all thanks to the engineering we're about to look at. And it actually gets better. Not only do they barely sip power, but a good quality LED bulb has an incredible lifespan of more than 25,000 hours. To put that into perspective, that's literally years of continuous use without needing a replacement. But, as you might guess, to get that kind of ridiculous longevity and reliability out of a product, the manufacturing process has to be absolutely flawless. Now, before we hit the factory floor, let's just make sure we're on the same page with the basics. LED stands for Light Emitting Diode. I know, it sounds a bit technical, but this wonderfully simple technology has completely revolutionized our homes, hospitals, and even entire cities because of how bright and efficient it is. Think about how we used to make light. The old way was, well, pretty terrible for efficiency. We basically just heated up a piece of metal wire inside a glass bulb until it got so incredibly hot that it glowed. It wasted a massive amount of energy just creating heat. The new way? We pass electricity directly through a tiny semiconductor chip to make light. It's an elegant, direct, and honestly brilliant leap in tech. But getting that tiny chip to work reliably every time you flip a switch, that takes some serious doing. Step 1, ingredients of light. Let's look at the raw materials. It is honestly mind-blowing how much goes into a single basic bulb. Look at this list. The star of the show is obviously the LED chip itself, that tiny semiconductor. But factories are taking in a whole bunch of other stuff too. Printed circuit boards, polycarbonate diffuser domes, and electronic driver components like capacitors, resistors, and integrated circuits. Then you've got the physical hardware, so copper wiring, aluminum heat sinks, and the standard metal pieces. And here's the kicker. Every single one of these pieces is rigorously inspected the second it arrives. Machines verify the exact dimensions and electrical specs. If a batch is even slightly off, boom, rejected. It never even sees the assembly line. Step 2, building the brain. Circuit board assembly. This is where modern automation just completely steals the show. Giant rolls of printed circuit boards are fed into an SMT line. That stands for surface mount technology. First, you have these incredibly fast pick-and-place robots just zipping across the boards, dropping thousands of tiny components into place every minute. Next, the boards glide through a reflow oven, where perfectly controlled heat melts solder paste to lock every piece down permanently. And then, the most critical moment, mounting the microscopic LED chips. This requires absolute perfection. Literally a fraction of a millimeter off, and the bulb's brightness, efficiency, or lifespan is completely ruined. But here's the thing. That little electronic brain needs to communicate with your house's power grid, and that is where the driver comes into play. Think of the driver as a translator. Its entire job is to take the heavy, alternating current coming out of your wall socket and translate it down into a smooth, low-voltage direct current that those tiny semiconductor chips actually need to operate. There's zero margin for error here. Without this compact little driver board, your bulb would just flicker wildly or literally burn out the second you turned it on. Automated machines pack these boards with transformers and control chips. And because it's the lifeline of the bulb, every single completed driver goes through intense electrical testing right then and there. If a driver acts up even a tiny bit, the system tosses it out immediately. Which brings us to step 3, bringing it together in final assembly. Next up, we add the heatsink. Robotic arms grab that finished LED circuit board and mount it to an aluminum base. Think of this as the ultimate bodyguard for those delicate chips. Because even though LEDs are hyper-efficient, they do still create a little bit of heat. This heatsink safely pulls that warmth away from the LEDs, which, by the way, is the main secret to hitting that massive 25,000-hour lifespan we talked about. From here, The physical assembly happens at lightning speed. Machines or technicians wire the driver to the LED board and snap the outer plastic housing around the electronics to lock it all in. Then, they pop on the translucent polycarbonate diffuser dome. This little dome is doing double duty. It keeps dust away from the LEDs, and it scatters the light so you get a nice even glow across your room instead of a blinding laser beam. Finally, the standard metal screw base goes on so it'll actually fit your lamp. In a matter of minutes, a pile of parts has transformed into a finished bulb.
Step 4. The final exam. Quality testing. So the bulb is built, but it's not done yet. Every single unit has to prove itself. Automated testing stations fire them up to measure brightness, color temperature, power draw, and voltage stability. They make sure the light output is exactly right. Then, thermal cameras actually scan the bulbs to make sure that aluminum heatsink is distributing heat properly. And just to be absolutely sure, random samples are pulled off the line and put through burn-in testing, which basically means leaving them turned on continuously for hours, sometimes days, just to catch any early failures.
And actually, it gets way more intense than that. These bulbs are put through an absolute physical gauntlet to meet international standards. We're talking drop tests to check how tough they are, violent vibration tests, crazy humidity testing, serious electrical safety checks. Only the tough ones that survive absolutely every single test are allowed to move on. The survivors of that gauntlet finally head to packaging. And shocker, this is almost completely automated too. Robotic systems perfectly slot the finished bulbs into their boxes. And every package gets stamped with the vital info you look for at the store: wattage, lumens, color temperature, the energy label, plus a batch number and barcode so the factory can track it. From there, cartons are sealed, palletized, wrapped, and shipped out to warehouses all over the world. So let's just zoom out for a second and look at the big picture. Highly automated lines are pumping out tens of thousands of these bulbs every single day, and they touch pretty much every aspect of modern life. We rely on this mass-produced precision technology to light up our homes, our cars, stadiums, critical hospital rooms, and yeah, literally even spacecraft. It really is just this beautiful symphony of robotics, electronics, and engineering. So I'll leave you with a question. Next time you walk into a room and flip a light switch, will you think about all those microscopic chips, the heat sinks, and the robotic factory lines hiding right there in that bright glow? It's so easy to take this stuff for granted, but as we've seen today, there's a whole world of hidden innovation inside every single bulb. Thanks so much for joining me on this explainer. Keep learning, and I'll catch you on the next one.